Hi guys, I'm back after a long break. I'm hoping your exams went well if you gave them in the October-November session. So today we're solving this math paper. This is Probability and Statistics S1, paper 5 from the Major 2020 series 9709, paper 5.2. I plan to solve the other math papers as well. I'm going to be uploading them week by week. Statistics followed by mechanics followed by pure math. I'm going to be done with the whole Major 2022 series by the end of this month. If you do like the math content, please do let me know. I am going to upload more often then. Also, before we start, I just want to show you something special. I actually launched the official site. I've posted it in YouTube. It's actually CIE paper solved. The link for my website will always be given down below in my videos from now on. So this is the overview of the site. It's pretty straightforward. The links for my socials are given here. This is the link for Twitter. Please do follow me if you use Twitter. This is the link for YouTube, as usual. Here you go. Please subscribe if you haven't already. Also, so you have access to the past papers and videos over here. I haven't uploaded O levels at IGCSE yet, only A levels. I'm focusing on the four subjects that I make videos of, especially. So what about something like math over here? We have access to, you know, all the variants. For example, the threshold, then MS52, QP52. Tell me if you like this site. I can edit it if you guys want. I actually made this myself. Uh, so here's the threshold for this paper. You have the mark scheme, question paper. So you can download all the papers from my site if you guys want. Also, I've also given links to my videos. For example, what if you want to check out a paper for math? This is Major 2022, paper 5.1. I have to edit this.
Hello.
Sure.
We're solving this
Yeah,
math
so you can
bit
watch
2.
this here. This is like
This is
interception video within one video.
9709.
And yeah, please do
Major
subscribe to the channel
2022.
if you haven't already. So yeah, that's all. Hope you like the page. Give me some feedback. Anyway, let's talk about the threshold. So for this paper, A was at 36, B was at 31. A was at 36, B was at 31. Then 24, 16, and 9, which was very low. 24, 16, and 9, especially E and D, they were very low compared to the other papers. 9, here you go. So if you compare them, A and B were quite the same, as well as C, but D and E were very low for paper 5.2 actually. So yeah, so let's see how it goes. Let's begin. Starting with question 1. I actually have a really bad cold, so I'm sorry if this interrupts the video at times. For n values of the variable x, it is given that this. Okay, so this is coded, this coded sum basically. So find the value of n. All right. So we know that the formula works like this: x summation of x minus 200 by n plus 200. So basically, you guys need to understand that if a minus is given in the code, to fix it, I need to apply a positive sign afterwards. Do you understand? That's how it works. So here you go. So this is the coded mean basically. If you add 200 to it, you will get the actual mean. Okay, and the formula for actual mean is actually like this: summation of x by n. So here you go. So you can input the values over here now. So we can write 446 by n plus 200 is equal to 6846 by n. So we can solve this equation now. 6846 by n minus 446 by n is equal to 200. 6846 minus 446. After LCM, we end up with 6400 by n is equal to 200. or basically n is equal to 6400 by 200. Here you go. We end up with an answer of 32. All right, so that's it. Moving on. Fair-sided, six-sided die has numbers 1, 2, 2, 3, 3, 3. It's rolled twice. The random variable x denotes the sum of the two numbers. Okay, so for this type of question, you actually need to draw a table like this. 1, 2, 2, 3, 3, 3. 1, 2, 2, 3, 3, 3. All right. So the we're basically looking for the you know sum essentially. So that's 2, 3, 3, 4, 4, 4, 3, 3, 4, 4, 4, 4, 4, 5, 5, 5 over here. 4, 4, 5, 5, 5, 5, 5, 6, 6, 6, 6, 6, 6, 6, 6, 6, and 5, 5, 5 over here. So out of 666, 36 options, 36 events, we are getting two only once. Okay, so what are the possible events that can occur? Essentially, we can either end up with a 2, a 3, a 4, or 2, 3, 4, 5, or 6, right? So I try to draw a closed table. Okay, that's what Cambridge wants, a table like this essentially. Now you get 2 once out of 36 times, just this once. You get 3, 1, 2, 3, 4, 4 times out of 36. 4 times out of 36 times. 4 in 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 out of 36 times. 10 out of 36 times. 6 in 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 out of 36 times. And 5 in 1, 2, 3, 4, 5, 6. Plus 6, 12 out of 36 times. Okay. So that's the math basically. That's it. You can simplify this if you want, or you could even give it to decimal places if you wanted. Okay. 3 significant figure decimal places, but this is fine. This is completely okay. I honestly always go with this invariably. By the way, you can reduce it, like you can write 4 by 36 as 1 by 9. That's okay, it's up to you. So expectation, we know that ex is equal to the value of x times the probability, so let's go for that. So expectation, you actually need to show the working. Okay, there is marks for that. So that's basically 2 times 1 by 36 plus 4 times 4, sorry, 3 times 4 by 36, then 4 times 10 by 36 plus 5 times 12 by 36 plus 6 times 9 by 36. And if you go forwards with this, you will get your answer. So that's basically 2 plus 12 plus 40 plus 60 plus 54 by 36. This gives you an answer of 168 by 36 actually, which can be written as 14 by 3 or 4.67 if you guys want. You can keep it as a simplified form. You can give it in simplified form. So we know that the formula for variance of x is actually the summation of x squared into p minus the whole square of expectation. All right. So let's do this again. So that's basically 2 square times 1 by 36 plus 3 square times 4 by 36 plus 5 square times 12 by 36 plus 6 square times 9 by 36. Wait, I missed 4, right? Sorry. Plus 4 square times 10 by 36. Sorry for my mistake. You should have written 4 earlier, but it doesn't really matter. Okay. So this is your summation of the squares. Obviously, you have to subtract expectation square. So basically 168 by 36 whole square. Make sure you don't use the 3 sig fig answer, 4.67. Make sure you use the fraction. Try to use the exact answer, all right? Okay. So after appropriate working, this ends up as 4 plus 36 plus 160 plus 300 plus 324 divided by 36, all right? So this minus 14 by 3 whole square, essentially 168 by 36 is 14 by 3. You end up with this answer. You end up with 10 by 9. You could also write it as 1 whole 1 by 9, that's fine, or as 1.11. Anything works, honestly, everything is fine. Or basically the complicated form, 1440 by 1296. Okay, honestly, anything is fine. I would personally go for 10 by 9 or 1 whole 1 by 9. Okay, a simplified form. That's what you're gonna get in the calculator. Okay. Moving on to question 3. This is a back-to-back stem and leaf diagram showing the diameters of 19 cylindrical pipes. This is the key it's given. Find the median interquartile range of company A. Okay, so 19. 19 is a odd number. So the median is actually the 19 plus 1 by 2. That's the 10th value. This is how you find the median for odd numbers. It's n plus 1 by 2, that value. Okay, so here's how you count. This is your first value, 1 2 3 4 5 6 7 8 9 10. This is your 10th value. Okay, so what does this mean? Essentially, it's 0.351, right? So this is actually 0.355. So the median is actually 0.355 centimeter. Okay, now about the interquartile range. For even numbers, thing is 19 numbers, how can you divide it? Basically, you can exclude the 10th value. Okay, you can exclude the 10th value. There can be 9 numbers on one hand side and the other 9 numbers on the other hand side. So basically, for odd numbers, you will exclude the median. Okay, I excluded the median so that I can divide the data into 2 equal parts. Look, this is the first, second, third, fourth, fifth, sixth, seventh, eighth, ninth value. On the other side, we have 1 2 3 4 5 6 7 8 9 values, 9 on each side. So for odd numbers, this is how you do it. You basically get rid of the median and divide the data into 2 equal parts. If you are given something like an even number, like 20 for example, rather than getting rid of a certain number, just split it into 2 parts. 20 can be divided by 2, so 10 parts or 10 numbers on one side and 10 on the other side. That's it. Now about the about q1 and q2. Sorry, we found out q2, that's the median. About q1 and q3. So basically, q1 is the median of the first half of the data, and q3 is the median of the second half of the data. Q1 is basically the 25th percentile, which is the midpoint of the first half. So basically, in the first half, we have 9 values. What's the median for the 9 values? It's basically 9 plus 1 by 2, which is the 5th value essentially. Okay, so this is the first, second, third, fourth. This is our 5th value over here. This is my Q1. On the other hand, we have 1 2 3 4 5. This is our 5th value. So that's our Q3 essentially. So IQR, the interquartile range, is basically Q3 minus Q1, which is 0.366 centimeter minus 0.348 centimeter. Hopefully that makes sense, guys. If you still don't understand, please comment down below. Also, a lot of you have been requesting S2 papers, paper 61, 62, 63, but I honestly did not have statistics 2 back in the day. I had P1, P3, S1, and S2. Sorry, I mean P1, P3, M1, and S1. So I really can't solve that actually. My bad. If we do grow in the future, I'll try to get people to solve those for you guys, don't worry. So keep on supporting the content. All right, so that's the IQR. All right. Draw box and whisker plots for companies A and B on the grid below. All right, so you have to provide the scaling. So let's take a look at the least value that we have. It's essentially this value, right? 0.331, and the highest value is 0.388. So essentially 0.331 and 0.388. So we need a scale from 0.33 to 0.39. Okay, so this can be 0.330. This is 0.340, 350, 60, 70, 80, 90. That's perfect scaling, guys. Zero point 0.360 and 0.350. Perfect. Okay, so this is my scaling. By the way, in the mark scheme, they did it in a different way. This is basically the length or something. Diameters. So diameter in centimeter. There are 33, by the way, in the scaling, but yeah, it's 33 times 10 to the power minus 2. You could also do it that way. That's fine. I just chose to use the exact values. Okay, so for A and B, right? So 5 values are important for a box and whisker plot. The least value, the highest value, Q1, Q2, and Q3. Let's go. So I'm doing A first because I have it written over here. So basically the least value is 0.334. 0.334, that's 4 units over here, right? Okay. It's 3, 3, 4. 1, 2, 3, 4. I'm gonna go with 4 units up and down. So here you go. This is my least value. Okay. Next one. 2 units up and down, I meant 4 in total. So key 1 is at 0.348. 0.348 over here. Here you go. Then Q2 is at 0.355. 0.355. Here you go. And 0.366. That's Q3. 66. 66 is over here. So this is my box. And about the whiskers, the last point, the highest value is at 0.374 actually. 0.374. Here you go. So we end up with this diagram for company A. This is company A. Now let's move on to company B, shall we? So the least value is 0.331, highest value is 0.388. So 0.331, 0.331. Here you go. And 0.388. Wow, that's really far away. Now the quarters are given. 0.346, 346, 352, 370. 352, damn it. 352, 370. These are honestly annoying, like drawing these graphs. Honestly, chapter 1, 2, 3 were really annoying from this one coursebook. Alright, so this is it for company B. Okay, so make a varied comparison. As you can see, the range is higher. Okay, both the interquartile range as well as the range in total, the highest value minus C square is greater for company B. All right, so we could say that it's more spread out. Okay, but you cannot talk about a certain value. Okay, you cannot talk about a certain value like the range or IQR. It must be in the context of the diameters of the pipes, basically. Do you understand? Or you could talk about the central tendency. Okay, so I'm gonna give you two. So you could say that the diameters of pipes produced by company B are more spread out, okay? Basically because they have higher IQR or range. Or you could just go for the diameter of pipes produced by company A has higher central tendency. Okay, due to a higher median. Okay, in general, extremely sorry, I have a really bad cold. I actually decided to make this video because I won't have free time soon. Like I'm free for like 2 more days, so I just want to get some content done. All right. So it has higher central tendency. All right. So now we have a few more questions left. Basically, question number 4, 5, 6, 7. All right. Let's do this. Not much left. So this is a question on normal distribution. The weights in kg of bags of rice produced by Anders have the distribution in 2.02, 0.03 square. All right. So we know that basically a normal distribution is like this, mu and sigma square basically. So that's the variance. Sigma square is variance, but 0.03 is the standard deviation. Find the probability that randomly chosen bag of rice weighs between this. Okay. So let's call this x. X is normally distributed. So probability that x is, greater than 1.98, but actually less than 2.03, yeah? So we end up with, to break this down, you know what to do. Basically bigger minus smaller. So basically that's px is less than 2.03 minus px is less than 1.98. You guys know how this works, right? So suppose if this is your binomial distribution, we are at 2.02 over here. Okay, so 2.03 is over here, 1.98 is over here. So basically we want this section over here. How can we find that? Remember, using the table, you can only find out values that are less than a certain value. So if you do px is less than 2.03, you get this region. If you do px is less than 1.98, you get this region. If you subtract that spot, you can get the orange area in between. Understood? Now we have to standardize it. How do we do that? That's basically pz is less than 2.03 minus 2.02 minus mu divided by the standard deviation, of course, which is 0.03 minus pz is less than 1.98 minus 2.02 divided by 0.03. Okay, 2.03 minus 2.02 divided by 0.03. That's 1 by 3 actually. So pz is less than 0.333. You have to give this answer to 3 decimal places. Okay, always remember that. Minus pz is less than 1.98 minus 2.02 divided by 0.03, which is, whoa, wait, 1.98 minus 2.02 by 0.03, which is minus 1.333. All right, so we have to change this negative value. So this will remain the same. If you want to change this value, this turns into 1 minus pz is less than 1.333. Do you guys know the logic behind this? Do you want me to show you? Wait. So look at this diagram. We are over here, right? 2.02. So this is minus 1.3333 basically. It's like this. Oh wait, we have to think about the normal the standardized normal distribution over here. Here you go. So in the standardized normal distribution, the mean is at 0. So the graph is like this. Here you go. This is 1.333. This is minus 1.333. So basically this section is less than minus 1.333. What does that mean? We are basically looking at this section over here. But you can't do it for negative values. In the table, you are only given positive values. That is exactly why I'm going to convert this to a positive value. How though? Basically, according to symmetry, this shaded region over here is the same as this shaded region over here. But we cannot find that directly. So what am I going to do? I'm basically going to find out, check this, I'm basically going to find out this region, alright, and then subtract, this is basically pz is less than 1.33, then subtract 1 from that. We're going to subtract this from 1 basically. As a result, we're going to end up with this area, which is the same as this area. So that is the logic behind converting this minus sign into 1 minus pz is less than this, alright. So let's move on then. So 0.333, this is not an inverse. We can just go for it directly in the table. So 0.333, so 0.333, so that's 0.6293 plus 0.0011. Okay, so we end up with 0.6304. Basically, I took this value because it's 0.33, and for the last 3 I took 11 and added it to the last 2 places to 93 essentially. Okay, so we end up with 0.6304 minus 1 plus 1.333. Let's check this out. 1.333, check this, 3. So 1.33, 0.9082, okay, 0.9082 as well as 3. 5 is going to be added, plus 0.0005. We end up with 0.9087. Okay, 0.9087, 0.9087. Let me check the mark scheme. Yeah, it's fine, it's fine. Plus 0.6304 minus 1, which gives us an answer of 0.5391. But all last answer should be given to 3SF, right? So this is 0.539. There you go. Okay, so let's do the next one. The weights of bags of rice produced by binders are normally distributed. Okay, so let's call this Y. Y is binomial distributed with mean 2.55 and standard deviation sigma. In a random sample of 5,000 of these bags, 134 weighed more than 2.6. So they're basically saying that Y is greater than 2.6 is actually 134 out of 5,000. What does that mean? 134 out of 5,000 is 0.02698. Y is greater than 2.6 is equal to 0.0269. Great. So guys, let's standardize this. We end up with so yeah, to change something greater than, I just taught you. So if this is 2.55, we are basically here 2.6. I want this region, right? Greater than 2.6, but there's no way to get it directly. So what do we have to do? We need to find out this region and then subtract 1 from it. So this can basically be written as 1 minus probability of y is less than 2.6 is equal to 0.02698. Understood? So that's basically p y is less than 2.6 is equal to 1 minus that, which gives us an answer of 0.9732. 0.973. Perfect. Okay. So now let's move on. So we can write this as pz. I'm standardizing it. 2.6 minus 2.55 divided by, you know, the standard deviation sigma is actually equal to 0.9732. Okay. So now we can go ahead. Let's look at the table. This is inverse. Okay. So for inverse, this is how you do it. 0.9732. You have to look for the number which is closest to it, 0.9732, but below it. So wait, we have the exact number, 0.9732. So we can just go for 1.9, 1.930. That's literally it. It's 1.930. Okay, so we can write that 2.6 minus 2.55 by sigma is equal to 1.93. So if you do solve this, you end up with the answer 2.6 minus 2.55 divided by 1.93. To 3SF, it's 0.0259. Hopefully that matches with you guys, and it matches with the mark scheme. All right, moving on. Done with 4 questions. Now for question number 5. In a large college, 28% of the students do not play any musical instrument. 52% play exactly one, and the remainder play 2 or more. Find the probability that the students play at least one. So what does at least one mean? One or more. So no instrument is basically 28%. So exactly one instrument is 52%. So 100 minus 28 minus 52 is 20%. So 2 greater than or equal to 2 is actually 20%. So what's the probability of playing greater than or equal to 1? It's basically 52 plus 20, which is 72%. Okay. So let's form a binomial distribution. X is binomially distributed. Okay, so we have a sample of 12 students. That's n comma p, right? So X is binomially distributed. We have 12 students, and the probability of success is 72% or 0.72. So we want more than 9. So that means Px is greater than 9. What does this include? This includes 10 students, 11 students, or 12 students, right? So let's begin. So 10 students, that's basically 12 C10, 0.72 to the power 10, and 0.28 to the power 2, plus 12 C11, 0.72 to the power 11, 0.28 to the power 1, plus 12 C12, 0.72 to the power 12, and 0.28 to the power 0. Right, so let's try to find this out. 12 C10, so rounded off to 3SF, it's 0.304. That is my answer. See if you guys get it. Please do comment below if you have any queries, and remember to subscribe to the channel. So my plan is I'm gonna finish S1, M1, followed by P1 and P3 within this month, hopefully. All right. So a random sample of 90%, 90 students are taken. So this is going to be an approximation. So let's write down the binomial distribution first. Fewer than 40 of these students play exactly one. So guys, exactly one. What's the percentage? That's 52%, right? So I'm gonna make a new binomial distribution. Y is binomially distributed there are 90 students, and the probability of success is actually 52% here, or that's 0.52 essentially. Okay. So we have to write down we have to convert it to you know, we have to convert it to a binomial distribution now. I mean a normal distribution. So let's use another word like v. V is normally distributed. So mean, we have to find out mean. Mu is equal to np, okay, and sigma square variance is equal to npq. So np is basically 90 times 0.52, and sigma square npq is equal to 90 times 0.52 times what's 100 minus 52, that's 48, right, times 0.48 basically. So what are the answers? 90 times 0.52 is 46.8. 90 times 0.52.48, 22.464. So it's 46.8 here, comma 22.464. This is my normal distribution, because we need standard deviation. Sorry, I mean we need variance and mean. We found that using NP and NPQ. That's mark 1. Now let's move on. Basically, according to the binomial distribution, we need fewer than 40 students. What does that mean? P y is less than 40. But this is literally impossible, right? Like how many times would you do it? So this is how you approximate it. So we are converting a discrete distribution to a continuous one. So if this is 40, this is 39, and this is 41. So fewer than 40 actually does not include 40. So it's basically over here. It does not include 40. It basically starts from 39 onwards. Do you guys understand what I mean? So this point, when you convert it to a continuous distribution, it's actually, this one is 39 by the way, it's actually the point between 39 and 40, so we can classify it as 39.5. Okay, so when you write this, you have to convert it to the binomial I mean the normal distribution. It becomes v uh, probability that v is less than or equal to 39.5. But if it was less than or equal to 41, sorry, if it was less than or equal to 40, like at most 40, not fewer than, I would have taken this region as well. It would be 40.5 then. But since it's fewer than 40, I cannot take that region. So it's less than or equal to 39.5 basically. Okay. By the way, this sign is not essential. You could just write it like this, but it has to be 39.5. Okay, so let's standardize this now. This turns into p z is less than 39.5 minus 46.8 divided by, of course you have got to do root over 22.464. okay, because you need the standard deviation, not the variance. 39.5 minus 46.8 divided by root over 22.464. That's basically z is less than 1.540 to 3 dp minus 1.540. This can be written as 1 minus p z is less than 1.540. Okay, so let's head out, shall we, to the table. Okay, so 1.540. So 1.5, 1, 0, 1, 2, 3, 4, 0 0.9382. 0 0.9382. And for 0, we don't have to do anything. So that's basically 0 0.9382. 1 minus 0 0.9382. Which is basically 0.06182 SF, and that should be your final answer. Okay, hopefully you guys understood this. I tried to clarify as much as possible. All right, moving on to the last two questions. I actually did this questions with my students. Crocodile. So last year, or this year basically, when my students gave this exam, after the exam they were all confused about a particular question, this one over here. and it turned out everyone got it wrong. So let's try to figure this out, okay? This was a very hard question, by the way, but we can do it. Come on. So basically find out the number of different arrangements in the 9 letters in the word crocodile. So the first thing you have to do in this is basically write down the word according to the letters crocodile. So that's basically double C, right? Double C, double O, R dial. Okay, so how many letters in total? 9. So for that, it's going to be, if you have no restrictions, just number of different arrangements, it's just 9 factorial divided by the number of repetitions, you see. So divide by 2 factorial times 2 factorial, because there were 2 C's and 2 O's. I plan to make a video on permutations and combinations in general, by the way. Hopefully soon. I'm going to get that out before your exam next May-June session. Find the number of different arrangements in the word crocodile, in which there's a C at each end and 2 A's are not together. Okay. So how to do this? Come on. So basically, we have 9 letters. 1, 2, 3, 4, 5, 6, 7, 8, 9. So I'm gonna put the C's here. So if you put 2 letters in a fixed spot and if they're identical, you don't have to do anything with them. Your job here is done. Okay. Now about the other 7 letters. You can do this math in 2 ways. Either you could find out the number where they're together and then subtract, or you could just apply the arrow method where you directly find out the scenarios where they're not together. Okay, so to do that system, just ignore the 2 letters that can't be together. So we've used up the C's and we're ignoring the O's. So we're just gonna end up using R dial. So that's 1, 2, 3, 4, 5 blanks for R dial. So for R dial, the number of arrangements is 5 factorial, and since there are no repetitions between them, we don't have to do anything. Now let's put the O's in. Usually the O's can be placed at the ends like this. However, since the C's have to be at the ends, those points are restricted. So how many positions do the O's have? Basically 1, 2, 3, 4, 5, 6 positions. So that's basically due to the 6 positions over there. It's basically going to be 6 P2. Out of 6 positions, I'm putting in the 2 O's. But since the 2 O's are identical, you have to divide this by 2 factorial. Since they're identical. Or you could directly just write 6C2. That's fine. You would get the same answer. Honestly, this is what the mark scheme does typically. But honestly, I honestly prefer 6P2. Out of 6 positions, I'm going to input 2 O's and divide it by 2 factorial. This is 100% fine. So let's do that. That's 5 factorial. 5 factorial times 6P2 divided by 2. 1800. That's your answer. In the mark scheme, they wrote 6 times 5 by 2 factorial, which is the same thing. 6P2 is basically 6 times 5. Okay. I prefer this. Now the other one where you can think of the O's being together. Okay, so let's think of the total arrangements where it doesn't matter where the O's are together or not. So the total arrangements include the C's at 2 ends, okay, C's at 2 ends, and in between we have 7 letters. So 7 factorial for that, R dial plus the double O. But since the O's are repeating, that's why we gotta go for a 2 factorial. This is your total number of arrangements where the C's are at the end. Okay, you have to take this scenario into consideration. Total arrangements where the C's are at the end. Next scenario, I'm going to put the C's at the end, but I'm going to put the O's together. In this arrangement, in the total one, the O's were together as well as not together. All scenarios were taken into consideration. Now we're going to put the C's at the end at first, okay? And in between, how are we going to deal with it? I'm basically going to put the O's together and then bring out R dial like this. Okay, so as the O's are together, they're going to be functioning as one unit. So this is one unit, this is my second unit, third unit, fourth unit, fifth unit, sixth unit. So there are 6 units in total. That is why I put a 6 factorial. They can interchange their spots, and the O's can shuffle their positions. That's why we have a 2 factorial, but since they're identical in the first place, that actually cancels out. So you can actually ignore this part. This writing this is not a necessity, it's up to you guys. But yeah, if you subtract this arrangement here, C's at ends and O's together. Okay, if you subtract this from the total number of arrangement where the C's are at ends, you will end up with your answer of 1800. This is the alternate route. Okay, hopefully you guys understood. Next, selection. Come on, very important. 4 letters are selected from the 9 letters in the word. Find the number of selections in which the number of C's is not the same as the number of O's. Okay, so we have CCR dial, CCOR dial. Wait up, CCOR dial. Basically, in these selection sums, what's the most important part? Basically, do not think of you know, like since you're repeating, since there are 2 letters that repeat, it's a tricky scenario. Like permutation can do it for you manually. Do you guys understand? But basically, in combination, sorry, automatically, permutation does it for you automatically. But for combinations, you have to do it manually. You have to think it through. Could I clarify? So let's begin. Find the number of selections in which the C's are not the same as O's. So we can go for 1C 2O. We can go for this combo. 1C 2O. We can go for the other one 2C 1O. Then we can just go for 2C 0 O's or 0C 2 O's, right? Or we can go for 1C 0 O's or 0C's 1 O. But some students might think, what about 0C0? You can't go for that because the number of O's and C's then become same. These are all the possible combinations. 2C2Os are not valid, as well as 0C0O. Those are not valid, okay? So if you do think of these in this way, you have 5 remaining letters that you can use from R dial, and you have 1 blank left. So that's basically 5 letters but 1 blank. 5C1 selections, it's always combination. 5C1 over here, 2C0s, 5C2, 2O0C, also 5C2, 1C0s, 5C3, and 1O0Cs, that is also 5C3. If you add all of these up, you get an answer of 50. See if you guys get it. This is 5. All the rest are 10. Hopefully it makes sense, guys. Moving on to the last and final one, the hardest one. This should have been worth more than 3 marks, by the way. Clearly. Find the number of ways in which the 9 letters in the word crocodile can be divided into 3 groups, each containing 3 letters, if the 2 C's must be in different groups. Okay. So, crocodile, CC, double O, R dial. Okay. So, do you want me to do this for you from the top? Come on. Let me do this. So, this is our collection of letters. CC, OO, R dial. Everyone was confused about this sum after the exam. So come on, let's do this. So we have 1 2 3 1 2 3 1 2 3. This is group 1. So in group 1, what I'm going to do is I'm going to put both those with a C. Okay, and the C will be in another group. It doesn't really matter where you put it, it's just going to be a loner. Okay, it doesn't really matter. Next group, this time onwards, I'm going to put the 2 O's together, but the C's will, both of the C's will be loners. Get it? This is group 1, group 2. Now for group 3, let's think about your imagination skills. I'm done with all the combinations where the O's are together. Now I'm going to think about keeping the O's separate. Now we can think of 2 combinations. Either one way where the C's will be with those, okay, each O, or in this combination, check this out, the O's will be separate, but one C will be with one O while the other C will be a loner. These are all possible combinations in the three groups. Do you guys get it or not? Okay, so I've kept the O's separately and the O's together. Then I thought about placing the C's. Okay, either when the O's are together, one C could be with those, one C alone. It doesn't matter which group. Then the both C's loners. Then with one the O's separate, either you could keep both C's with those or one C with one O, but the other C alone. These are all the combinations. Now we have R dial, basically the other 5 letters, and okay, so the mistake here would be writing 5C5, but it's not like that, honestly it's not like that, because this is like that sum with suppose 9 friends are going to go to a trip with 2 cars. The first car has 5 seats, the second car has 4 seats. So how would you solve that sum? 9C5 times 4C4, remember? Just like that, you need to divide it into groups. So this would be basically, out of our dial 5 letters, 5C2 times 3C3. Now you might be wondering, what if I put the C here? Would it be the same? Yeah, sure. It would be 5C3 times 2C2. You would end up with the same answer, by the way. You can check. You get the same answer. So 5C2 times 3C3. Okay. Next one. This will be um, they used a different combination. I'm just gonna use it my way. Like here I wrote 5C1, then I'm gonna go to the second group. I've used up one letter from the 4C2 times 2C2. So check this answer. 5C1 times 4C2 times 2C2. That's 30 basically. I get 30. Now in the mark scheme they did it this way. They fill these groups up first. This one, then this one. Check it out. It would be 5C2 times 3C2 times 1C1. 5C2 times 3C2 times 1C1. Check it, it's still 30. Okay, so it doesn't really matter. I'm just filling it up from left to right, okay, so that it makes sense for you guys. So 5C1 times 4C2 times 2C2, that's 30. And the first one was 5C2 times 3C3, which is 10. Great, guys. Okay, next one. So the next one had a catch. Okay, basically you guys need to understand that these two groups are essentially this the same. It's like arranging, like here in all the other ones, look at this one. This was unique, this was unique, this was unique, right? This was unique, this was unique, but this one was not unique. I'll tell you what I mean in a bit. You'll see. Basically, let's keep on doing it as usual. So this is going to be 5C1 according to my combination. Okay, okay, let's do the complicated one at the end. This is basically 5C1 times 4C2 times 2C2. Okay, which is 30 again. Now about the complicated one, group 3. Why is this so complicated? Come on, like what would you do initially? You'd do 5C1, okay, then you'd do 4C1, then you'd do 3C3, right? So that gives you a certain value. Let's see, 5C1 times 4C1, that's 20 probably. So you get 20, but here's the thing, it's kind of like arranging ABC. You end up with 3 factorial ways, right? But for A, B, B, you actually end up with 3 factorial by 2 factorial ways. Why? These B's, they're the same, right? So you have to make a consideration for that. Do you guys get what I mean? So these two groups are exactly the same. Their only difference is the letter like R, D, I, L, or E, the one you put in actually. Okay, so as a result, just doing this isn't enough. You need to divide your answer by 2 factorial to make a consideration for the same group over there. As a result, you end up with an answer of 30 plus 30 plus 10 plus 10, which gives you an answer of 80 in total. This is your answer. So yeah, this was very complicated. Actually, this was very complicated. See if you guys get this. So in 1, we had unit groups. In 4, we also had unit groups. Now, what about 2? Why didn't I divide anything over there, if you're wondering? Because in 2 and 3, you can see that there are quite similar groups. Like we had a group with 1C over there in both. And here we had 2 groups with OC and OC. But you guys need to understand that one letter doesn't really make a difference over here. The issue arises because there are 2 letters over here. As a result, if you don't divide by 2, you're going to consider the same case twice. Do you get what I mean? In the question, it was already said that the 2 C's must be in different groups. That's why it doesn't matter in group 2. But here it does matter. Because suppose you can put R here, DILE, or couldn't it be this way? Like you could bring, D here and R here, ILE. Why should you consider it twice? As a result, since they're the same thing over there, so the number of possibilities has been reduced by 2. Basically, RD and DR, they're the same. Similarly, IL and LI, they're the same. Then ED and DE, they're the same. Do you get how I'm reducing scenarios? That's why we divide by 2, okay? There was an alternate way to do this sum, by the way. If you're interested, I can also teach you that. Let's learn the alternate way. So here we can subtract. So basically they want us to find the C's being in different groups, okay? But what if we kept them in the same group, the 2 C's, okay? So check this, 1 2 3 1 2 3 1 2 3. What if I kept the C's together? 1 2 3 1 2 3 1 2 3 1 2 3 1 2 3 1 2 3. So I'm keeping the C's together. Now the O's can be arranged differently. Either I can, put the one O here, one O here, or I can put one O in each different group, or I can just put the two O's over here. Does that make sense? Now, what will this one be? These are unique, right? So this is basically 5C2 times 3C3, which is 10. Okay, so these are also unique, and remember I told you having one doesn't really make a difference, okay? Because we are not selecting the same thing actually. It only matters when there are 2 letters. These are unique, so it doesn't really matter. So it's basically 5C1 times 4C2 times 2C2, which is how much? That's 30. Next, 5C1 times 4C1 times 3C3, which is 20. So 20 plus 30 plus 10, that gives you an answer of 60 in total. These are scenarios where the C's are actually together. Okay, got it? Now we need to subtract this from the total ways of making all the groups. Let's see. So in the total ways, we're going to make 3 groups, right? So what's the method actually? We have 9 letters, but 3 groups. So it's like this: 1 2 3 1 2 3 1 2 3. So that's basically in the first one we have 9 letters but 3 blanks. So 9C3 1 2 3. Now we have 6 letters but 3 blanks. 6C3 times 6 3C3. Okay, in the mark scheme they did it differently. They wrote 9C6 into 6C3, which is the same thing. Okay, it doesn't really matter. But since the O's and the C's are repeats, do you guys get what I mean? Since the O's and the C's are repeats, we have to take something into consideration. Okay, we have to take a few things into consideration. Basically, this is beyond the scope of our syllabus. You guys don't need to know this. I would personally opt for this method I taught you on the left hand side. Basically, because the O's have repeated twice, we multiply 2 over here. Also because the C's have repeated twice, we multiply 2 here. We also multiply a 3 over here. This is typical the combination where you have 2 letters which repeat twice, as well as 2 letters which repeat twice. We have to go for this specific combination, because in the total number of ways there will also be some cases where repetitions will occur. Okay, there will be a few cases where repetitions will occur. What do I mean by this? Because there are some cases where this happens. OCOC, remember? This is a case which we will get. Okay, so we need to make a consideration for that, because we're getting the same thing, right? And there are other factors. You don't need to know the details about this. But basically, after doing this is the total number of ways. You end up with 140. Now, if you subtract 60 from 140, you end up with C's not together. Okay, my bad. So I'm gonna give you more details about this in the comments, like why this happens later on. But for now, you just have to just go with this one. Okay. Also, if you like the content, please subscribe to the channel. It will help me a lot. And please do visit the website to solve more papers and see more videos. All right. Okay, so more details on this in the comment section, but this is beyond the scope of our syllabus. Okay, we do not need to know this. We don't need to know the details. We just need to know this method. Okay, that's fine then. Okay, last one, number 7. Hannah buys 12 chocolate eggs that each contain a sweet. The eggs look identical, but Hannah knows that 3 contain a red sweet, 4 contain orange, and 5 contain yellow sweet. Each of Hannah's 3 children in turn randomly chooses and eats one of the eggs, keeping the sweet it contained. Find out the probability that all 3 eggs chosen are the same color. So you have the manual approach or the combination approach. So we know that we are choosing 3 sweets. So all the events will be 12C3 in the denominator. If we want all 3 red ones, we're gonna go for 3C3. If we go for all 3 orange ones, we're gonna go for 4C3. And if we want all yellow ones, we're gonna go for 5C3. So red, orange, yellow, if you add this up, you end up with an answer of 3 by 44. Okay. So this is the probability that all 3 are same color. Okay. What about the other route? This is the manual route. Red, red, red. Orange, orange, orange. Yellow, yellow, yellow. So red 3 by 12 times another red 2 by 11. Total number of sweets will decrease, also the number of red sweets. And so on. See if you guys get it. And please do tell me if you have problems. It's pretty straightforward. It's a common sum. Okay, but I would honestly go for the root above. It's much easier, right? We don't need to do the subtraction. Next, for a conditional probability, find that all 3 eggs chosen contain a yellow sweet, given that all 3 children have the same color sweet. What you need to understand is the word given is the most important. The wording, the sentence after given is the condition. So the condition is all 3 children have the same color sweet. So this is how you write it. P, you start a bracket, you give this line over here. The condition has to be given after that line. So the condition is all of them are the same color, and we are going to find out the probability that all of them are in fact yellow.
So the condition will go to the denominator. That is actually your answer from part 1. So denominator will be 3 by 44 over here. And the numerator will actually be this answer over this answer over here, triple yellow, or basically this one over here, 5C3 by 12C3, because we're choosing 3. They want the probability of getting yellow sweets. So yellow, 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 divide by 3 by 44. Okay, which gives us an answer of 2 by 3. Or you could opt for 0.667. That's up to you. All right. Last one. Find the probability that at least one of Hannah's 3 children chooses an egg that contains an orange sweet. So guys, to do this, the best approach is actually, like, this is the easiest approach. Just go for a selection where Hannah's children do not pick orange eggs. Okay. So we have 3 red, 4 orange, and 5 yellow. So picking no orange, what does that mean? We either pick from 3 red or 5 yellow. That means 8 red or yellow sweets. So the probability of selecting no orange switch is 8C3 divided by 12C3. That's 14 by 55. So guys, remember that choosing at least one means Px is equal to 1, 2, 3. Okay, these include all of them. Or this can also be said as 1 minus Px equals to 0. Basically 1 minus, if you subtract the probability of choosing 0 from 1, you will get the probability of choosing at least one orange egg. Okay, so if I subtract this answer 14 by 55 from 1, we are going to get our final answer. Otherwise, it would have been very complicated. Honestly, you could do it. Like, you could think of the manual circumstances: triple orange, double orange, one yellow, double orange, one red, single orange, double yellow, single orange, double red, one orange, one yellow, one red. That would be too many cases. Okay, so you don't need to do that. Rather than that, this method is much better and much more concise, right? So remember this wording. Okay, so guys, that is all. So remember to subscribe to the channel. I'm gonna link the paper for May June 2022, paper 5.1 up here, and the paper for May June 2022, paper 5.3 down here when I solve that paper. And this here, I'll link the playlist for this one. Also remember to subscribe to the channel and check out my website. It would help me a lot. Alright, see you guys.